Hello, welcome to another edition of Skillforge. And today we're going to be talking about discrete structures, particularly algorithms in discrete structures. So in our previous session, we had talked about basic methods of proof. There is some slides that are posted on the site, so you can go check them out. But today we're going to be talking about discrete structures and algorithms basically in discrete structures and how to actually go about these algorithms and so on and so forth. So we're going to have a basic understanding. Then we're going to try to see if we can generate our own algorithms or have an understanding of what an algorithm looks like. All right, without further ado, we can begin. So what is an algorithm? Just put this guy here. So what is an algorithm? An algorithm is a set of step-by-step instructions that describe how to perform a task. Okay, it is made up of three basic building blocks, which is sequencing, selection, and iteration. So iteration is basically this guy here, the kind of a loop structure. Sequencing is basically just sequence here, and selection is basically if else statements, or if this, if that, or if this then that, if that then this. So basically an algorithm is made up of sequences, meaning sequence of operations like do this, do that, and do this. Selection, where if this guy gives out a positive value, do this, or if not, do that. Then if this guy does this, do this. Then if not, do that, or stuff like that. Then iteration, basically just looping around. So this is the basic structure of how everything looks like. So an algorithm is used for solving a problem or performing a computation. They are widely used throughout all areas of IT, right? And some characteristics of algorithms include well-defined inputs and outputs. They are clear and unambiguous, meaning that they are not, how can I say this? They are not ambiguity. Ambiguity basically means that it's not known. For lack of better terms, like it's not known. So the clear and unknown basically here. So they are clear and ambiguous, and they must terminate after a finite number of steps. So an algorithm has to stop somewhere, right? It's not an infinite loop, it's not an infinite matrix, it has to stop somewhere. So they are finite, okay? All right. So key fundamental concepts here is that sequence is a step-by-step execution. Selections are basically decision makings, meaning if statements and whatnot. Then iterations are loops, meaning that for, while, etc., etc. So we're talking about sequence here. We say that the definition of a sequence refers to a step-by-step execution of instructions in a program, right? The computer executes statements one after the other in the order in which they're written. So when you write code in Java, right? Let's just say you have x equals to 5, y equals to 10, z is equals to x plus y, right? When you have this type of orientation here, the program is going to execute in this order. Okay, let me just get my pen here. It's going to execute in this order. So that's sequencing, and algorithms work in that particular function. So the key idea is that the order of execution matters, right? Each step depends on the previous one being completed. So if you try to access, let's just say, a point before it has been defined in memory, then it's not going to actually work. It's going to give you an error, logically speaking, when you're writing code and whatnot. So that's the situation. That's with sequencing, right? So selection is basically decision making, which is if statements and whatnot. So the definition here is that selection allows the program to make decisions based off certain conditions. It uses conditional statements like if, else if to control the flow of execution. So the key idea here is that the program evaluates a condition and executes different blocks of code depending on whether the condition is true or false. All right. So an example in pseudocode could be, with age equals to 18. And if age is greater than or equal to 18, then you can print that you are a dot. Else, if this statement is false, so here we can have a true there, and then we can have a false statement like that there. So you got true and false, and then here if age is greater or equal to 18, you print that. Otherwise, if it is less than 18, then you are a minor. So this even goes back to basic concepts in programming, right? So you have that and you have this, and you have an idea of how everything works out. So iteration, these are loops. You can have for loops and while loops. And the definition is basically that iteration allows the program to repeat a block of code multiple times. So this is done using loops like for and while. So a for loop is used when a number of iterations is known in advance. So for example, let's just say you have for I from 1 to 5, print I, right? So we know when our loop is ending. Okay, so we know how big our loop should be, where it should end and whatnot. But then a while loop executes information based off a condition, whether it's true or false, right? So let's just say this. A while loop here, that's just my explanation, but a while loop is used when a number of iterations is not known in advance, and when the loop continues as long as the condition is true, like I mentioned earlier. So here we have count equals to 0, right? And then while count is less than 5, so meaning while count is less than 5, this less than is kind of like a condition statement, whether it's true or false. So this function checks if count is 0, right? So sorry, if count is less than 5. So count being 0 here, it's going to keep executing until count is 5 or above. That means that the compiler now says that it's false, right? So from this point up until the time 5, time 5 reaches, it's going to be true. But then when it reaches 5 and above, the statement becomes false, right? But then how do we actually change these variables here? So we increment here. So this is where increment operators come in, right? So count plus 1, meaning that we increment this guy here so that this condition becomes false eventually. So remember, as we mentioned earlier, algorithms are finite and they don't last forever. They have to stop indefinitely, right? When it comes to programs in the real world, especially games, right? Game development and whatnot. Python particularly has got a function called, we've got a while function, right? And then that while function keeps on going for as long as the window is open. So when you press like a little X button on your window, what happens is that the while condition turns into false, so it closes. So remember, iterations or algorithms are finite. They are not infinite algorithms. Otherwise, you risk memory leaks and whatnot and everything. So there's that. So the keywords that are going to be used in algorithms basically is algorithm, right? We've got return. This guy just basically tells us the output that we're going to have. If else for, conditional statements, and true false to show what's happening within the system. So these are the terminologies that we're going to use throughout this particular tutorial. So I suggest that you familiarize yourself with them. Okay. So the first example of an algorithm is finding the maximum of two numbers. So the format of algorithms when you're answering questions is that you have algorithm there, you start with algorithm, then the name of your algorithm, then the parameters that are inside the algorithm, okay? So here we have find max, A, B, right? And then we say, if A is greater than B, then return A, okay? So here what we're trying to find is that if A is bigger than B, then our output, remember here, return is for output, right? So return A becomes our output there. So let's just say if you're writing code in Java, you would say that sum is going to be equal to the greater number here, or big, or whatever. The point is, what we're trying to get out of this algorithm is the biggest number, right? So you've got your precondition. Let me say your precondition. So your precondition basically just says that the things that I have already in my algorithm, right? So our preconditions are that we should have A and B, okay? Our post conditions or our output is that we are supposed to get the biggest number between A and B. So that's basically what an algorithm just talks about, okay? So here we say that between the two values, if A is greater than B, then return A, right? Meaning that we've gotten our output. However, if A is less than B, then we return B, then we end our if statement. So you see here that in pseudocode, we are nesting our code within this particular function, right? And then we started our algorithm like that, so we have to end our algorithm. That's how it is. If we were to draw this, we would say that, how can we do this? Here we have our input, right? Our input is going to be A and B, if I'm not mistaken. A and B, right? Then here we have our diamond. Okay, our diamond. So our diamond says that if A is greater than B, so if A is greater than B, so here we can have a true and we can have a false here. So we can have a false there. This is F. Oh, actually not false. We can have no, and we can have yes. Something like that. So we got a yes and a no there. So we can say that if A is greater than B, right, then our output can just be something like return A, right? Else return B. Else return B. So that's basically our algorithm in general, right? That's how you would write it out. Something like that there. Okay. Next up, we have this other algorithm here. And you see that the notation is a little bit different. Okay. Sorry. Okay, yeah. So here we have sum of first n natural numbers, right? So this is an example of a loop. So how this would happen here is that we see that we've got a different orientation. So we have our algorithm and our algorithm name, right? And we've got our parameters, which is n. So here our precondition is that we have our value n, right? And what we're supposed to get as our output is the sum of the first n natural numbers. So just put that somewhere there. So we say sum is equal to 0, but then here, because we're using pseudocode, we don't particularly use equal to, we use an arrow, right? So sum is equal to 0, right? Or 0 is assigned sum, okay? Then for I, which is assigned 1 to n, right? Do. So a 4 has got do here as well. So we've got for I, the identifier there, and then how many times we're iterating through this guy here, right? So here for I, which is assigned 1 to n, do sum, which is assigned sum plus 1. So sum plus I there. So for as many number of times n is there, it's going to keep on iterating by one. Then we end 4. So notice that there's a syntax here, 4 and end 4 here. This is the syntax that you use, okay? When you're answering questions, this is the pseudocode that you use, okay? So for I, 1 to n, do sum, which is equal to sum plus 1, or plus I. Then end 4. Then you return the sum here. So you see that the sum is declared outside the for loop, and then we're returning the sum there. In Java, this is reminiscent to Java and also identifiers and whatnot and everything, but this is the basic algorithm that gets the first n natural numbers. So you start with algorithms, then you end with algorithm there, like that. Okay, then we use factorial of a number using recursion, right? So recursion is the concept. Recursion is the concept that talks about getting the function itself as a parameter of itself, right? So basically we're saying that we have a function here and then it's referencing itself. That's what we call recursion, right? So we get a function and then it references itself, which is here. So we have our algorithm and factorial n. So if n is equal to 0, then return 1, right? So meaning the factorial of, because we know the factorial of 0. How do you put this? The factorial of 0 or 0 factorial is equal to 1, right? So the factorial of 0 is equal to 1. So if n is equal to 0, we have return 1. However, if it is not 0, then we return n, this guy here, multiplied by this function minus 1. So you've seen how we are recursively calling back this factorial here, right? So we're calling this factorial function here, and we're calling it back within the return function there. So this is a concept that is known as recursion in programming. Yeah, so we end our if statement there, and then we end our algorithm. Okay, so with that being said, we also have a linear search algorithm, which is an iterative algorithm there. How can we do this? How can I represent this as a okay, let me try to represent this. So here we have our initial part there, then we have our condition statements. Okay, so here we say sum is equal to 0. So what we do here is that 0 to n. So here we say that it's sum equal to n, something like that. It's sum equal to n. If no or false, then what we can do is we can come here and we say that sum plus 1 s plus I. Let's just say this is just simplified to help you understand how to actually implement this. S plus I. Then we come back to this guy here. Then we come back to this guy. Then we continue checking this condition. Is sum equals to n? No. Continue. Is sum equals to n? No. We continue. But then if sum is equals to n, which is true, then what we can do here is we stop and then we output sum like that. Then we end. So ending, I think we put 0 there and we got 0 there, something like that. So I know this is not the standard way of doing things, but here we've clearly shown that we've gotten sum which is 0 there, and then we've checked it here. So is sum equals to n, right? So here what we're doing is that we're checking recursively. Sorry, we're checking iteratively if sum is equal to n, because our condition is that for 1 to n, right? For 1 to n, do this. So if it is not equal to n, then we increment this by the I. Then we continue, we come back, and then we check, we continuously check until we reach s is equal to n. Then afterwards, now that's what we can output our s, then we can end there. This is not an accurate presentation, but this is how it looks, or this is how basically it operates. Okay, so here again we have our algorithm, we have our parameters a and x, and then we see that a is our array, right? Linear search algorithm, we're getting an array, we're getting a number n, and we're going to getting a value x. So for I is equal to 0 to n minus 1, this is for arrays. Remember that arrays start from the array index 0. That's why we're doing that here. So here for I equals to 0, meaning we're starting from the array point 0 to n minus 1. Because if we say n minus 1, meaning if we're going to say from 1 to 5, then n minus 1 is going to be equal to 4. Right? Let me just do this. Let's is 1, this is 2, this is 3, and then this is 4. So 1, 2, 3, 4, 5. So you see here, right? If our array has got the size of 5, right? We start from index 0. So meaning we have 1, 2, 3, 4, 5. Okay, but then we've started from array index 0 because that's the syntax for arrays. So there's that. Okay. Yes, that's that. So if a at index I is equal to x, then we return I, meaning we found our index. So we are searching here, right? We get an array, and then in that array now, we have our index here. This is the size of the array. So this is the array here. This is the size of the array there. And then this is what we're looking for. Okay? So within this 5 here, if array at I equals to x, right? Within this loop here. So if we're looking for 2, right? Let's just say that these are the actual values that are within the array, right? So if we find that the value x is equal to 2, right? X is equal to 2 there. So this thing is going to continuously or recursively loop around until it finds x is equal to 2 within this array, right? And then if it finds this array here, then it returns the index. Okay? So we end our if statements, then end for, then return -1 if it's not found. Okay? So that's basically how a linear search algorithm works. For now, I think this is the first that you can look at. Next year, when you get into your third year, you're going to look at data structures and algorithms, which talks about a lot of other algorithms. But for now, you can just do a linear search and you can get that. So the conclusion to this is that you have your basic control structures, where you've got your if-else, which is selection statements, you've got your loops, which is a for or while, then you've got your recursion functions, which are functions that call upon themselves. Then algorithm examples could be the finding the maximum value, which is selection, sum of the n numbers, which is uses a loop, and then factorial, which uses recursion. This one I don't recommend that you continue because unless DMZ wants you to do it, it's better you just focus on what you can. And then you got linear search, which is uses iteration, like so. So if you have any questions, please feel free to leave a comment, and you can also text in the WhatsApp group. Then we can get into answering your queries. Otherwise, thank you so much, and we'll be seeing each other pretty soon. Take care.